Hello friends, now we have to find out a particular integral by using a shortcut method which is depend upon different functions which is present at right hand side of linear differential equation. Here are some notation: phi of d or phi of d square with the function of d. The first case is if we have a linear differential equation is of the form phi of d into y is equal to f of x, where the function is exponential e raised to power ax, then the particular integral is equal to 1 upon phi of d into e raised to power ax. In this case, we have to replace this d by a. Therefore, the particular integral becomes 1 upon phi of a into e raised to power ax. It is exist if and only if phi of a not equal to 0. But if phi of a is equal to 0, then we have to multiply this by x and we have to take a derivative of this phi of d with respect to d and write down the function as it is. After that, we have to replace this d by a. We get a particular integral in this way. It is also exist if and only if phi dash of a not equal to 0. This process we have to continue up to denominator becomes non-zero. This is our first case. We have to go take a next case. If the function is sine of ax or cos of ax, then particular integral is equal to 1 upon phi of d square into sine of ax or cos of ax, and this d square we have to replace by minus time a square. Therefore, your pi become like this: 1 upon phi of minus time a square into sine of ax or cos of ax. Again, it is exist only if phi of minus of a square not equal to 0. But if it is equal to 0, again we have to multiply it by x and take a derivative of this phi dash of d square with respect to d. Will get 1 upon phi dash of d square. Write down that function as it is and we replace d square by a square, and therefore pi become like this. But it is again exists for if this term not equal to 0. We'll continue. If it is equal to 0, we'll continue the process till denominator become non-zero. In third case, if your function is hyperbolic sine and cos, it is same as previous one, only d square by a square will get the same result, but only we have to replace d square by a square here, not minus time a square. In next case, if the function is e raised to power ax, then particular integral is equal to 1 upon phi of d into e raised to power ax, and this d is replaced by log of a only. And if the function is e raised to power minus ax, then d is replaced by minus log of a. The fifth case is if we have a differential equation as phi of d into y is equal to f of x, for f of x is equal to x raised to power m, where m is a positive integer. Then we have to expand phi of d by using binomial expansion by using these formulas. If x has a power m, we expand with respective series of m term, because the m plus 1th derivative of x raised to power m is equal to 0. The next case is if a function is e raised to ax into v, where v is any function as we used earlier, then particular integral is equal to 1 upon phi of d e raised to power ax into v. In this case, we replace d by d plus a. Therefore, pi is equal to e raised to power ax. We have to finish the role of this function e raised to power ax by putting d is equal to d plus a and write down v as it is, and after that solve this by using previous cases, as our v is a earlier function. The next case is if we have a linear differential equation of the form phi of d into y is equal to f of x, and f of x is equal to x into sine of x or x into cos of x, then we have a formula to find out the pi, which is equal to x minus phi dash of d upon phi of d into 1 upon phi of d, and write down the function which is present, either it is sine of x or cos of x, and we have to solve it by using case second. The next case is if f of x is equal to x raised to power m into sine of x or x raised to power m into cos of x, then we have to convert this sine or cos in terms of exponential function by using Euler's formula and solve it by using case first. Thank you.